Okay, today's lesson is multiplying and dividing radical expressions. So when multiplying or dividing radicals, you have to multiply or divide the numbers that are outside of the radical together, and multiply or divide the radicands together, and a radicand is the number that is inside of the radical. And then be sure to write your final answer in simplest radical form. So the first example on your notes shows you that 2 radical 3 times 4 radical 6 is equal to 8 radical 18. And this just shows that the 2 on the outside of the radical is multiplying with the 4 to give you 8. And the radical 3 times radical 6 gives you radical 18. And then to just simplify that, radical 18 gets broken down by 9 and 2. And between 9 and 2, 9 would be the perfect square. Square root of 9 is 3. So that 3 radical 2 is what is replacing radical 18. And we can't forget about the 8 that needs to multiply that 3 on the outside. So 8 times 3 is 24, which means your final answer is 24 radical 2. So number 1 on your note says radical 5 times radical 3. Since they're both radicands, they're numbers inside of the radical, we can just multiply them together. And when we multiply them together, we'll get the square root of 15. And since 15 has no factors that are perfect squares, that's our final answer. For number 2, we have 3 radical 6 times 2 radical 5. So we multiply the numbers that are outside of the radical together. So 3 times 2 is 6. And then we multiply the radicands together. And the square root of 6 times the square root of 5 is radical 30. And that is your final answer because 30 has no factors that are perfect squares. Number 3 is a little different. We have 2 binomials that we have to multiply, so we must double distribute. So we're going to start with 4 times 4, which is just 16. And now 4 times radical 8, well I should say 4 times a negative radical 8. Since the 4 doesn't have a radical and the radical 8 has nothing else to multiply with, you just write them next to each other. So we have minus 4 radical 8. And now we have radical 8 times 4 is a positive 4 radical 8. And radical 8 times radical 8 is, we have negative radical 64. So now we have 16, and we have the negative 4 radical 8 and the positive 4 radical 8 will just cancel, minus the square root of 64. Since 64 is a perfect square, we are just left with 8. The radical disappears, and 16 minus 8 is just 8. And for number 4, it's 2 minus 3 radical 7, the whole thing squared. We can't just square what's inside the parentheses, we actually have to write it twice. So let's get rid of this, so we have plenty of room. Okay, so to write it twice, we have 2 minus 3 radical 7 times 2 minus 3 radical 7. So we're going to distribute and say 2 times 2 is 4, and 2 times a negative 3 radical 7. Remember, only the numbers outside of the radical are truly multiplying together, so we have negative 6 radical 7. And now negative 3 radical 7 times 2 is negative 6 radical 7. And negative 3 radical 7 times negative 3 radical 7. So the negative 3 times the negative 3 is a positive 9. And the radical 7 times radical 7 is radical 49. Now if we just combine some terms, so we have 4 minus, so the negative 6 radical 7, negative 6 radical 7 is a negative 12 radical 7. And then we have plus 9 And the square root of 49 is 7, so plus 9 times 7. Can simplify this a little bit more. We have 4 minus 12 radical 7 plus 9 times 7 is 63. And now we can combine like terms. So we have 63 plus 4, which should be 67. And then we have minus 12 radical 7 as our final answer. Can't be simplified any farther. Number 5. So now we have radical 3, and that radical 3 needs to multiply and distribute to everything inside of the parentheses. So radical 3 times 4 radical 8, only the radicands, the number inside the radical, are multiplying. So only these numbers are multiplying, so we have 4 radical 24, since 8 times 3 is 24, plus radical 3 times 2 radical 6 would be 2 radical 18. And now radical 24 and radical 18 can both be simplified because they're not quite in simplest radical form. So we look at radical 24 first. That can be broken up by radical 4 and radical 6, 4 being the perfect square, and the square root of 4 is 2, so we have 2 radical 6 there. But remember that 4 needs to be brought down before we forget about it, so we have 4 times 2 radical 6 plus, let's write the 2 there first so we don't forget about that one, and let's work with radical 18. So 18 is broken down by 9 and 2, and 9 is the perfect square, so the square root of 9 is 3, so we have 3 radical 2, and that's going to be in place of the radical 18. So now we can simplify this some more. So 4 times 2 is 8, so we have 8 radical 6, plus 2 times 3 is 6, radical 2, and this is our final answer. And for number 6, we have radical 20 divided by radical 5. They're both numbers that are radicands since they're inside of the radical. So we keep the radical, and 20 divided by 5 is 4. And since 4 is a perfect square, our final answer is just 2. Number 7. So the numbers outside of the radical are the 9 and the 3, so 9 divided by 3 is 3. Radical 18 divided by radical 2 is radical 9. 9 is a perfect square, so that becomes just 3, and we can't forget about the 3 that was already in front of the radical. 3 times 3 is 9. That's our final answer. And then for number 8, radical 7 squared is the same thing as radical 7 times radical 7, which is just the square root of 49, and the square root of 49 is simply 7. And you might be able to jump from this to the final answer since you know that the opposite of squaring is square rooting. So they pretty much cancel each other out. And that concludes the notes for today.